Oh, hello there, what's up? Oh my, it looks like I was either crying or either I was screaming. But yeah, how are you guys? How have you been coping with online classes, such as also watching this video? Hopefully, these videos continue to inspire you, continue to teach you new things about Earth, about plate tectonics, and how those different types of processes affect us here living at the surface of the Earth. In the previous video, I gave to you an introduction of the different types of plate boundaries, such as convergent, divergent, and transform fault boundaries over here. Now, for this video, we are gonna be talking about convergent boundaries. But we are gonna be taking to an even more specific type of convergent boundary. And that is the convergence of continental and oceanic plate boundary. This here is what a convergent boundary, of course, an actively deforming region where two plates of fragments of the lithosphere move toward one another and collide. Now let us look at this picture first and analyze it. Let's go through the exercises of this activity over here. First question: what type of crust is plate A? Now, it's very easy to notice that plate A is gonna be beneath the ocean. So the type of crust that plate A is going to be an oceanic crust. Okay? Plate A is an oceanic crust. Number 2, what type of crust is plate B? What is the other kind of crust that we have here on Earth? We have oceanic and we also have continental crust. Now, so what you can see here, this here is a continental crust because there is no water, there is no ocean, and also there are mountains. Right? So that's why plate A is an oceanic crust and plate B is going to be a continental crust. Let's go to question number 3. Describe what happens to plate A as it collides with plate B. So again, we have discussed this is a convergent boundary. So plate A, the lithosphere of plate A, and this oceanic crust will be here. As it collides with plate B, there is a force making this collision happen. What is that force called? Yes, it is called slab pull. Now, as oceanic crust A, plate A here, is colliding with plate B, plate A is going to sink beneath. Again, S-I-N-K, plate A is going to sink beneath plate B. And there is a name for this kind of process. What is that called? It is called yes, it is called as subduction. So let me just write that in for you guys. The process called subduction. What is the correct spelling? It is S-U-B-D-U-C-T-I-O-N. It is subduction, where an oceanic crust sinks beneath a continental crust due to the force of slab pull. Another reason why this happens, okay, is that plate A or all oceanic crusts are gonna be denser compared to continental crust. Okay? So, oceanic crusts will be denser compared to a continental crust. That is the reason when an oceanic crust converges or collides with a continental crust, the oceanic crust will always sink. One of the many reasons is the types of rocks that are present in the oceanic crust. As far as I know, continental crusts are made of granite. They're less dense. Oceanic crust also contain a lot of water particles, a lot of particles that come from the ocean, making them a lot denser compared to an ocean, compared to a continental crust. Okay? Let's go through the next few numbers over here. Number 4. What do you think will happen to the leading edge of plate A as it continues to move downward? So, sir, saan yung leading edge? This here is the leading edge of plate A, yung nag-uuna. So, we are discussing about the layers. We know that plate A is, as it sinks beneath plate B, it's going to a layer that is going to be a lot hotter because that area is going to be the asthenosphere. The asthenosphere is part of the mantle. Okay? So, when plate A sinks, it will reach the mantle, and as it reaches the mantle, all of the plates here are going to melt because of the heat and also because of the pressure. Okay? So the answer to number 4, the leading edge of plate A will melt because it reaches the mantle. The asthenosphere too. So number 5, what is formed on top of plate A? So there is the first landform that we have ever discussed. This here, what is the landform formed on plate A? This here is already in the picture. It's called a volcanic arc. Sir, what is a volcanic arc? A volcanic arc is a series of volcanoes formed due to the subduction of an oceanic crust beneath a continental crust. Or in other words, volcanic arcs are just usually a series of volcanoes. Now there are actually two landforms formed due to the convergence of oceanic crust and continental crust. Okay? There are two landforms. We have number 1, volcanic arc, and number 2, trench. We will go through what a trench is later. Okay? And let's answer the final number here. As the plates continue to grind against each other because they're going towards each other, what other geologic event could take place? Now, there are a lot. Number 1, earthquakes. When tectonic plates collide, they will produce earthquakes when the faults give in. Another thing, since a volcano is being formed here, it is safe to say that volcanic eruptions will take place. And another thing too, since this is located in the ocean, if earthquakes happen in the ocean, most probably there will be tsunamis. Okay? So, let's go through the questions all over again. What type of crust is plate A? It is an oceanic crust. Number 2, what type of crust is plate B? It is a continental crust. Number 3, what happens as plate A collides with plate A collides with plate B? Plate A will sink, and this process is again called subduction. Number 4, what do you think will happen to the leading edge of plate A? It will sink because it reached the mantle. What is formed on top of plate B? It is called a volcanic arc. And the other landform that is created is a trench. As the plates continue to grind past each other, we have earthquake, volcanic eruption, and tsunamis. So, as I said a while ago, we will be looking at what kind of trench is being described in the image a while ago. So, a trench is a depression on the seafloor, so it is a sinking. Okay, something like this. There are topographic depressions on the seafloor. Let's just look at a few pictures. Now, one of the most famous trenches, oceanic trenches, is also called as the Marianas Trench, or the deepest trench in all of the earth. Right? The Marianas Trench is formed by the convergence of the Pacific Plate and the Philippine Plate. So let's just also look at that right now. The Marianas Trench. So you can see here. Okay. Let's look at this picture over here. There. Over in Google. So credits to all of the sources of my pictures from Google that just went out of Google, all of the websites. Thank you so much. Deep Sea Challenge 3D by National Geographic Channel. By the National Geographic Channel. Okay, let's just open this image in a new tab. There. You'll be able to see. Okay, over here. This here is the Philippines. And this here is the Marianas Trench. This is a depression. Dalom kayo siya, guys. And this here is the Pacific Plate. So, as the Philippine plate is colliding with the with the Pacific Plate, a trench is formed. So, sir, how is a trench formed? When two plates collide, the edges of those two plates will bend as one sinks beneath each other. As they sink, nagbend yung landform, yung mga edges nila. And thus, creating a trench. Okay? So, in this lesson, we were able to discuss the convergence between a continental crust and an oceanic crust. We know that when these two kinds of plates converge or collide with each other, the oceanic crust will always sink. It will always sink because it is denser, because it is an oceanic crust. Another thing is that when this plate sinks, it will melt because it will reach the mantle. The magma over here, okay, the molten rocks that are formed here will rise because they are less dense because of the water. So when this sinks, the molten rocks here are less dense, so they rise. And then that's when they form volcanic arcs and a series of volcanoes. Another thing that is formed is the trench over here. So let me just quickly illustrate that for you guys. Okay, so when two plates collide, okay, let's just look at this over here. Let's say this is an oceanic plate. As it sinks, it will melt because of the heat, because of the pressure, okay, because of the mantle. So there will be tiny rocks that will rise, tiny molten rocks. These are molten rocks. They will rise and form a series of volcanoes. Okay, a series of volcanoes. Let me just put some conduits and some vents there. These types of rocks rise because they are less dense. They are less dense because they have water inside of them. And when water is introduced through a lot of heat, it will turn into steam, thus making the molten rocks here, these are molten rocks, rise. And there are also a lot more factors that influence this. There is the pressure, there is the density of these molten rocks, thus forming a volcanic arc. Okay, so we have a volcanic arc here, and we have a trench over here. Okay, those are the landforms that are created through the convergence of oceanic crust and continental